Hello everyone, welcome back to MAT1033. So in the previous video we talked about how to solve a linear equation, and the reason we call it linear equation because it is a line, it represents a line, and in those examples we see that those equations just contain only one variable x. Now, if it represents a line, think about that. If we can go ahead, okay, look at this. If on a coordinate system, I pick 2 points, right? I pick 2 points. Then you see that I can draw a line, okay? Out these two, out any 2 points, we can draw a line. And point has an x and y component. So this is x1, y1, and this is x2, y2. So a line contains many points, and each point has component x and y. So what does it mean by that? It means that a linear line, or linear equation, it can contain 2 variables, right? If it can contain 2 variables, then we can describe a line on a coordinate system. So in this section, in this video, I would like to discuss a linear equation 2 variable. I will be introduced 3 form linear equation in 2 variable, and we're gonna do some example and how we're gonna convert among those linear equation. Okay, all right, so let's get started. Linear equation in 2 variable. Okay. All right. Now the first form of linear equation in 2 variable, we call that a standard form. Okay. So what does standard form look like? It looks like as follow: ax plus by equals c. So you see over here we have 2 variables, x and y, and ABC is just constant. It's just number. It's just number. It could be fraction if it wants it, but could be positive number or negative number. All right. But for example, what if I have a linear equation like this? 2x plus 3y, okay, equal 6, for example. Okay, so you see over here we have A is 2, B is 3, and C is 6. So this is linear equation, and it represent a line. So what the line look like? So let's see. We can go ahead and graph this linear equation 2 variable or not. Okay, and we're going to use a very traditional method of graphing. So we just go ahead and plug in a point, right? Okay, so I'm going to go ahead and I'm going to plug in some point over here. How about we put x equal 1? Okay, x equal 1, so we know 2 times 1 plus 3y equals 6. So from here we can solve for y. 2 plus 3y equals 6, and then we have 3y equal 4, and y equal 4 over 3. So if x equal 1, we have y equal 4 over 3. Okay, how about x equals 0? X equals 0, you have 2, 0. plus 3y equals 6. Then we have 3y equals 6 and y equals 2. So we have 0, 2. How about if I put negative 1? Okay, let's see. Okay, what happens? So we have 2 times negative 1. 3y equals 6. So we have negative 2 plus 3y equals 6. So we're gonna have 3y equals 8. How about if I change a little bit? Okay, let's change this x equals negative 3, so that is I want to have a better number. Negative equal 3, y equal negative 3. So this is negative 3 over here. Okay, this is not big enough. Okay, so we have 2 times negative 3. So you're going to end up with negative 6. Okay. And over here you're going to add with 12. And you're going to add with y equals 4. So when x equals negative 3, y equals 4. Okay. Actually, we just need 2 points to grab a line. We don't need this point because it's kind of hard for you to snap this point over here for over 3. So I'm gonna just need this point and this point, and I'm gonna put it on the coordinate system. So you will see that we have 0, 2. So 0, 0, 2 is right over here. I have negative 3, 4, negative 1, negative 2, negative 3. 1, 2, 3, 4. So you have a point right over here. Okay, so we have a point right here. So now we can go ahead and connect them to get a line. Okay, let me get a ruler. Okay, let's say that. Oops, kind of hard. Oops, I need to go down a little bit more. Okay, there you go. It's not a perfect line, but that's okay. Okay. Now, I want you to notice this one. The point right over here, you know, where's the line over here? It cut the y-axis. It cut the y-axis right here. We call this point is y-intercept point. Y-intercept point. Okay. Now, if I go ahead and continue, extend the line, you will see that our line is gonna cut the x-axis. Okay, our line is gonna cut the x-axis right over here. Okay, this point right over here. Okay, we call the x-intercept point. Okay, so how are we gonna find the coordinate of this one? So in order to find the y-intercept point, okay, in order to find the y-intercept point, we're gonna go. We already have it over here. In order to find the y-intercept, we replace x with 0. Then in order to find the x-intercept point, we replace y with 0. Alright, which is I'm gonna do now. So I'm gonna go ahead and replace the y with 0 and try to find the x. So you have 2x plus 3, 0 equals 6. Then you have 2x equals 3. Then x equal, x equal 2. So 2x 303 times 0, 0 is 6. So x equal 3. So the x intercept point will be 3, 0. So this 3, 0 right here. Okay, so that is the method to find x-intercept point and y-intercept point. And the concept of x-intercept point and y-intercept point is not just applied for linear equation in two variable, but it applies for any function later on when we talk about function, and we can find x-intercept point and y-intercept point of any function, okay? Using this method. You see the one I have in red color and in orange color, guys. So that's the method of finding x-intercept point and y-intercept point, okay? Now let me give you another example. Now in this example, I'm gonna add some fraction over there. Equal 1. Now this one is also linear equation to variable in standard form. What a value is just a fraction. Over here we have a fraction, but we can go ahead and get rid of the fraction easily. So if I go ahead and multiply everything by 10, so if I go ahead and multiply by 10 over here, okay, multiply by 10 for each of them, then you see that we're gonna end up with 5x minus 6y equal 10. 10 you simplify with the number 5 here give you 2, 2 times 3 give you 6. So you see that? Okay. It's the beautiful ABC value as whole number or whole number right here. So this is in standard form. Okay. Now, another form, okay, I want to talk about is the slope-intercept form. Well, I have to say that every time we talk about linear equation in two variables, 90% of them, 90% of the time that we mention about the standard form. However, when we look at the slope-intercept form, okay, y equal to mx plus b, that's the slope-intercept form. It also contains two variables, right? It's also contains two variables. Okay, is right. Over here is a y and over here is x. So, in my opinion, okay, I don't see the difference between equation, linear equation into variable form in standard form or in slope-intercept form. To me, it is also this one I can call this two variable. Okay. However, because the textbook say that the linear equation into variable form, they just mention this form. So just go ahead and take it, okay? But it doesn't mean that this one doesn't have two variable. They also have two variable over here. Okay, now let's try to explain what does mean by the slope over here. Over here we have the m value. Okay, the m value over here we call the slope. Okay, and the b value here we call the y-intercept value. Y-intercept value, okay, not y-intercept point, because every time we talk about point we have to put in order pair form. This one, you see, it's just the b value, it's not a form. Now from here we can get the y-intercept point. Now I'm going to put in the point form, so the y-intercept point could be 0 comma b. Okay, now we need to understand what the slope means. So if you notice, you see the line sometimes is slanted upward or slanted downward. Okay, being slanted upward or slanted downward, actually that's what the slope is. So actually the slope is actually later it tell you how slanted the line is, or how steep the line is. Okay, and the slope could be positive or negative. If the slope is positive, then your line is kind of slanted upward. Okay, and if the slope is negative, then your line is kind of slanted downward. Now what happens if the slope is 0? Okay, if the slope is 0, actually we have a horizontal line. Okay, we have horizontal line. And how about if the slope is what if we have vertical line? Okay, what if we have vertical line? If we have vertical line, then the slope does not exist. Okay, so we have undefined m value. So the slope does not exist when we have vertical line. Okay. All right. Now for the slope equals to 0, think about that. If the slope equal to 0, right? If you go ahead and replace over here, if you had replaced the m with 0, then 0 times x is just 0. So what we have left is just y equal b. So if the slope is 0, the horizontal line has equation y equal b. Okay. Okay. However, if we have undefined slope, then okay, then your equation could be the vertical line, and in that case the equation will start with x equal a value. Okay, x equal value. For example, x equal 2, then you're gonna have a vertical line at 2. X equal -3, then you have vertical line at -3. Okay. All right. Now let me give you oh, I forgot one more thing. The slope over here, we also can calculate it based on the information given. Let's say that they give us 2 points. Okay, let's say that they given us 2 points on the line, given the coordinate of 2 points on the line. Okay, let's say the coordinate A is x1, y1, and the coordinate of point B, okay, is x2, y2. Then we can find the slope by y2 minus y1 over x2 minus x1. So this one right over here, we call the slope formula. Okay, we got slope formula. Okay, we can give it a 2 point. We can find it to we can find the slope by using this formula. And this is very important formula because later on when you watch the video, you will see that we can use this formula to get a slope and write a linear function, linear equation in slope intercept form. All right, let me give you an example. All right, I can have a linear equation like this: y equal to 1 over 2x plus 2. Okay, so you see over here the slope over here is 1 over 2, so slope over here is positive, so that we know that the line is going upward like this, and the b value over here is 2. Okay, I mean the y-intercept value is 2, so it means we have 0, 2 as the y-intercept point. So if you go ahead and graph this line, okay, I'm gonna go ahead and graph this line. Okay, we can use the slope value and the y-intercept value to graph this line. Okay, so in order to graph this, we're gonna go ahead and start at 2, which is its b value over here is 2, so we're gonna start at 2. Okay, I'm gonna start at 2, 1, 2. Okay, we're gonna start over here. Then, okay, the slope information is tell you very important. The slope value over here, they tell us that very important how slanted the line is. And I forgot mention that the slope over here we can also define by rise over run method. Okay, so this is also equal to rise over run method. So over here on the top is y. So if it is positive, you see that positive 1, it means that we're going up 1 unit. So we're gonna go up here at 3. This is 2. Then over here positive 2, it means we're going to the right 2 unit. Okay, so it's right over here, number 1. So from here, I can go ahead and connect them, and we can get a line. Okay. Okay. So a disadvantage of this slope-intercept form is that you see when we have slope-intercept form, we don't know the coordinate of this point, where actually we can find it. You see that if we apply the method of price overrun, then we can just draw the line, we can grab it, but we don't know where it's cut it on the x-axis here. So in order to find where it's cut over here, so this is a y-intercept point right here already. So this is y-intercept point. Okay. Now in order to find x-intercept point, we do as usual. Okay, we already mentioned the method of find x-intercept point. So in order to find x-intercept point, we replace y with 0. So I'm going to go ahead and replace the y with 0. So you have 0, 1 over 2, x plus 2. Then you have negative 1 over 2, x equal 2. So x equal negative 4. So over here, the coordinate will be negative 4. Negative 4, 0. Okay, so right over here. So just you see this a little bit off. It's just a little bit off. 1, 2. Going up 1, going to the right 2. Yeah. All right. So now what we learned out of this example, so we know that if the rise, so remark, I'm going to put a remark right here. Okay, so if the rise part is positive, then it means you going upward. Okay, if the rise part is negative, we going downward. Okay, we go downward from the y-intercept value. Okay. Okay. But if the run is positive, we're gonna move going to the right, going rightward. And if the run is negative, we go leftward. Okay. So remember that. Going leftward. Okay. Now, so far you see that both of them has x and y intercept. Oh, they both of them have also have x and y variable. It means what? It means that given the standard form, we can go ahead and convert to slope intercept form. Standard to slope intercept. They all related to each other. Okay. Okay. So I have a standard form like this. Alright, I'm gonna go ahead and convert into slope intercept form, okay? So that we can define the slope. You see that if it is in standard form, we don't know the slope. We don't know the slope. Now we had to convert it to slope intercept form. Then we know the slope. Alright, so in order to convert to slope intercept form, so we have to isolate the y. So I'm gonna go ahead and bring this over here. Okay, so add them both side by 3. Then I divide everything by negative 4. Okay, divide by negative 5. I put negative on the top. Okay, then 5 over 4. Okay, so you see I successfully convert to slope intercept form. So right over here is slope. Okay, So this is y-intercept value, so it means you have y-intercept point to be 0, comma, -5/4. This is where your line is gonna cut the y-axis. Okay, right over here, right this point right here. Okay, good. And in the third example, I will show you how to find the slope using slope formula. So they give you 2 points. For example, the one is -5, 1, and point B is 2, 5. So we can find the slope. Okay, we can find the slope easily using the slope formula. So it will be m equal to y2 minus y1 over x2 minus x1. Now, if you are not familiar and this is the first time you learn, then I recommend you to label them. So I'm gonna go ahead and label them. So this is x1, this is y1, x2, y2. Then I'm gonna go ahead and plug it in. So you have 5 minus y1 is 1 over x2 is 2 minus, but x1 is -3. So negative, but there's another negative. Okay, so you're gonna put like that. So be careful right there. Okay, so you're gonna end up with 4 over 5. Negative times negative is positive. 2 plus 3, 5. So the slope over here 4 over 5. So it means you're going up 4 units and going to the right 5 units. Okay, this slanted up. Okay, good. All right. So we already covered 2 forms. Now let's see we can cover the last form. Okay. This last form we call the point slope form. Okay. So in order to have a point slope form, we need to have a point. Okay, given a point. And the coordinate of this point is x0, y sub 0. Then you're gonna have point slope form as follow: x minus x0 equal m. You see, we also have m. Sorry, so it's not y, it's not x, it should be y. Y minus y0 equal mx minus x0. You see that? This one also 2 variable, right? Because you see that they have x and y. They have x and y. So actually all 3 form are 2 variable form. But again, I already told you that every time they mention 2 variable form in the textbook, they on my MATLAB, they just talk about standard form. But actually all 3 form over here, 2 variable form, they all contain them. That's why we can convert from one form to another form easily. Okay, and in the previous examples right here, I already show you how to convert from standard to slope intercept. Alright, now let me give you an example. Now let me give you example in point slope form. What if you have y minus 2 equal -3 x plus 4? So this is point slope form, and you see the slope over here -3. The point over here is 2 and -4. Okay, because the formula is negative already. Okay, so x0 is actually -4. Okay, and now look at it. I'm gonna go ahead and convert this to slope intercept form for you. Okay, so in order to convert to slope intercept form, you just go ahead and distribute it, and I'm gonna go ahead and add both sides by 2. There you go. See that? Slope intercept form. And from slope intercept form, you can convert to standard. I'm gonna go ahead and add both sides by 3x. Then you're gonna end up with standard. There you go. This standard. This slope intercept. See that? All 3 forms is related to each other easily. Yeah. Now, in example number 2, Let me give you something else. And what did I have? Plus 3, and I have a fraction over here. Again, don't panic if you see the fraction. It's just a number. Okay. Again, I'm going to go ahead and convert it. So slope over here 1/2. But before I go ahead and distribute it, I'm gonna go ahead. So I guess I'm gonna go ahead and convert the slope into set form. So I can go ahead and distribute now. Right now, you don't need to get rid of the denominator because the slope can be fraction. So 1/2x minus 1/2 times 4 is 2. Okay. And I subtract both sides by 3. I'm gonna end up with something like this. See that? So from here I have this is the y-intercept point. You see that? Y-intercept point. So that's the bad thing about point slope, right? You don't know the y-intercept point. But if you put in slope-intercept form, you know the y-intercept point. Okay. Then from here we can go ahead, convert it to standard. I'm going to go ahead and get rid of the denominator here. I'm going to multiply both sides by 2, which is give you 10. Then I subtract both sides by x, so I'm going to end up with this. Okay, so you see that we have a value is -1, b is 2, and c -10. And the standard form is actually the form it does not give you a lot of information about the slope, right? Nor does the y-intercept point. We don't know anything about the line if it is in standard form. So in order to know more about the line, you have to convert standard to slope intercept. Okay. All right. So this video is just a quick introduction of how a linear equation two variable look like and all the three form of linear equation. Later on, we will be discussing how to derive linear equation using point slope form and slope intercept form. Okay. All right. I'm gonna stop the video here. If you have any questions, let me know. Okay. I'll see you next time.